Alright, oh shoot, it is not, okay. Alright, hello guys, my name is Kit. In this video I'm gonna be doing this problem. So, consider this titration. You could pause and read all of that. So what is the pH after this many milliliters of KOH added? So, Mr. Pratt, he didn't give us the starting amount of 0.03 molarity of the benzoic acid. So I'm just gonna start with 55 milliliters because I can. Alright, and someone just... For the first one, the only values you need to use are the benzoic acid, right? I don't even know how... Remember how I did. It's gonna... Wait, 1 second. Not sure. Okay. Okay, so I already did A, B, and C, so I'm just gonna do D. Alright, so usually for these problems I just start with the Ka value. So 6.3. Oh wait, what is it? So the Ka of benzoic acid is 6.3 E -5. So let's see if that... Oh, okay, that shows up on the camera. So 6.3 E -5 equals, and I know the top is going to be the reactants and the bottom is going to be the products. Alright, so now we just need to figure out where the values will be. So I know that there's 60 ml of KOH, and 60 times 0.015 is going to be less than 0.030 times 0.055. I just know this because the values just don't seem to match that well. So like I intuitively just know that this is going to be a higher mole content than the 0.015 molarity KOH with the 60 milliliters of KOH. So because of that, I know that there will be C6H5, there will be the benzoic acid left over, and I know that all of the KOH will be converted to the conjugate base, which is the benzo... I don't even know what the base of this is called, but yeah, I know that there's going to be the conjugate base. So because I know that all of this, all of 60 ml is going to be the conjugate base, what I usually do is I just start with the molarity, so 0.015. So 0. Oh no, it's not focusing. Okay, 0.015 m of the KOH. Alright, and then I know that I'm gonna have to multiply it by the milliliters, which is 0.060 liters, because 60 ml is equivalent to 0.060 liters. Alright, and then afterwards I know I'm gonna need to divide that by the total liter content to find the new concentration of the conjugate base. So the new total volume will be 60 ml plus 55 ml, which is 115 milliliters, which equates to 0.115 liters. Alright, so because I know that this is... Oh, ngã邊呢個盒係咁，你拎你放晒嗰啲嘢入係咁，我哋 return 係佢哋 send 我哋個 return for free 係咁，我哋 return。So 你要 return？冇得㗎，陣間就冇得。Okay， 有一陣我整 video 而家。That was my mom. Okay, so let's see. Okay, so since this is the starting reactant, we know that it's going to be an additive change, so it's going to be plus X. Alright, and then there's two reactants. There's the conjugate base, and there's also the what's it called, hydrogen ion, so it's gonna be just X. Alright. And some of you should already know like what these values will be, so yeah, I'm not gonna spend my time explaining it. In the bottom, we know that's gonna be the acid. So let's see. Since all of this is going to react with 0.015 m KOH of the 60 ml, is going to be the mole content of this minus the mole content of this. So to write that out, it's going to be 0.030 m of the benzoic acid. I'm not sure if you can see this correctly. 0.030 m of the this should be better. Okay, let's see. Somewhat better. Okay, 0.030 m of the benzoic acid. Alright, times the amount of milliliters that I start with, so 0.055, because there's 55 milliliters, 0.055 liters. So that's going to get me the mole content of the benzoic acid, and then I need to subtract by 0.015 m of the strong base. So 0.015 m of the strong base times 0.060 liters. Alright, and then you divide this by the total volume to get the new molarity. Then since this is the reactant, it's going to change negatively, so it's going to be a negative X. Alright, now what I usually do next is it's better for me to see the camera. What I usually do next is I just put all of this into my handy dandy calculator. So I get X equals, let's do this. Can't see it that well. Maybe if I, yeah, whatever. You guys don't need to see this. Okay, so I'm just gonna put in the values. So I have a solve function on my calculator, which is awesome. 0.115. I just change up a few values because I've done this before. 0.6. 1.5. 0.060 times that. Alright, and I get an X value of 5.17414 e to the negative 5. So this is also going to be the molarity content of the H plus ion. So to find the pH, you just do negative log of the molarity of the H ion. So you get, put this in the calculator. You get negative log the value 4.28. 4.29, which equals the pH. Alright, so to check this, I can't really check it because I don't have the answer, but what I do have is the answer to the last problem. So let's see. So the last problem, it was 55 ml of KOH. So what this means is that the pH of the last value should be lower than the pH of this value. So the pH of this value is 4.21. Is that 20? That should be 20. Let me see. 4 point. Yeah, so that's, oops. Just fix that. handwriting fail. This is 2. Okay. So the pH of the last value is 4.21. Alright. And then the pH of the new value is 4.29. So it actually increased. Now this makes sense because there's more base added. There's more base added, so it makes sense that the pH would be higher. And yeah, that's just one problem. And I still have 2 more to go and an essay. Okay, bye. Hope this helps.